In mineral terms, there are three kinds of rocks. There are igneous rocks, formed from the cooling and solidification of the lava. Sedimentary rocks, slowly formed from the fragments of different stones and other residues throughout a long physical and chemical process. Metamorphic rocks. These are residues of igneous or sedimentary rocks that have changed their mineral constituents due to long periods of high pressure and temperature. What we know as slate belongs to this category. Etymology. The term slate comes from the Old English word slat, which may derive from the French word esclat, which means to split. Slate is a dense, fine-grained metamorphic rock, which is the result of crystallization of layers of sediments, so as to develop its special characteristic which allows the rock to be split cleanly into flat, parallel sheets. In basic terms, about 400 million years ago, layers of mud sediments accumulated in certain parts of the oceans. Movements of layers of the earth and the formation of mountains exercised considerable pressures into these sediments. In addition, this squeezing would produce high temperatures, making them metamorphose or crystallize. Because of this metamorphosis of the mineral elements and the alignment of the layers, the rock can be split apart into thin sheets, parallel to the original sediment. The main constituents of slates are chlorite, quartz, and mica, plus some other additions. But of course, there are lots of variations on these, which will result in color variations. Slate rock, containing a high proportion of chlorite, exhibits a lustrous gray-green color, like riverstone, probably the best slate in the world. Blue-gray slates are often found to have abundant graphite, like domes or saria. And there is also the blue-black slate color that contains bluish iron additions like Del Carmen. The planes that allow the slate to be split into tiles are called cleavage. The width of these plates will restrict the thinness to which the slate rock can be split into sheets. The slate is also constituted by grain, which is trace of the original sediments. The grain may be defined as a series of fine lines, parallel along the slate. Some slates exhibit irregular small isolated bumps, known as inclusions. These features are often harmless, but it could be a problem if these inclusions present a high content of ferrous minerals or calcium carbonate, because these could rust. The versatility of the Slate for architectural design has no limits. It offers the amazing feature of being easily cut into strips, or any shape. Also, it can be perforated and trimmed without altering its natural and attractive appearance. This gives an incredible flexibility to the designer for special features such as cones, domes, turrets, curves, swept valleys, close-mitered hips, eyebrows, etc. Also, slates can be produced in special shapes in order to create decorative elements, special effects, or innovative design concepts. All these features put natural slate ahead of other roofing materials. The SSQ Technical Department can advise on design possibilities and restrictions. Formed by nature to hold back the elements and to remain inert in the most adverse environments, natural slate is a product that even modern science could not have better devised. The lack of a pore structure makes slate almost 100% resistant to water, oil, and other fluids acting upon the surface. This means to say that environmental contamination like acid rain or strong marine breezes with high salt contents will not penetrate the microscopic structures of its constituents. Also, it is resistant to cycles of sun, rain, and snow, even during the same day, ensuring its lifespan of almost 100 years. This metamorphic rock, known as slate, is non-combustible. Besides, it does not transmit heat, and it can survive much higher temperatures than even concrete. Also, the sun and other environmental elements do not alter its original color. Once slates have been installed, the roofs will not require maintenance or cleaning.